Here we will look at subtracting fractions using area models. This standard builds on the work students did in fourth grade, where they subtracted fractions with like denominators. It also requires students to apply what they learned about finding equivalent fractions, since their work will involve fractions with unlike denominators using related fractions. Related fractions are fractions like what you see here with 1/2 and 3/8, in which one denominator is a multiple of the other. Students in fifth grade are also expected to use benchmark fractions to assess the reasonableness of answers. It is important to note that students should have ample experiences using models to build understanding and to allow them to use reasonableness to find a common denominator prior to using the algorithm. So let's look at how we can use area models to subtract 3/8 from 1/2. To begin with, we'll estimate so that when we have our final answer, we can check its reasonableness. Using our knowledge of benchmark fractions, we can just leave 1/2 as it is, since that is one of our benchmark fractions. And now when we look at 3/8, we just need to think about whether that is close to 0, 1/2, or 1 whole. And I know 3/8 is close to 1/2. It's just 1/8 away from 1/2, while it's 3/8 away from 0 and 5/8 away from 1 whole. So again, we would say 3/8 is close to 1/2. And we know that 1/2 minus 1/2 would give us 0. So we know that our actual answer should be close or equal to 0. So we'll begin by creating our area model. So let's create a model to represent 1/2. So we'll shade in 1/2 in this area model. And now we know what we need to subtract from this is 3/8. So I will draw an area model and we'll split this into 8 equal parts. And there we have 8ths, and I will shade in 3/8. And so here we have 1/2, and here we have our 3/8. We know that in order to be able to add or subtract, our fractions have to have the same denominator. And so what we need to look at here is, are we able to take one of these models and split it into as many parts as the other? And when I look at our model for 1/2, I can see that that model can be divided up so that it is in 8 equal parts, just like our model is for 3/8. So I'm going to go ahead and split this model for 1/2 into 8 equal parts. So, now you can see that this model has been split into 8 equal parts, 1, 2, 3, 4, 5, 6, 7, 8. So instead of that area model representing 1/2, we now have it split into 8ths. And then we just need to look at, well, how many 8ths do we have shaded in? And we have 1, 2, 3, 4. This tells us that 1/2 is equivalent to 4/8. Now that we have the same denominator, we're ready to subtract. We just need to take 3/8 away from our 4/8. At this point, students may want to draw a new area model and shade in the 4/8 and then subtract from there. Students can also use this area model that they created in the beginning to show the subtraction. That's what I'll do here. So let me just change to a different color here. And so again, we know that we need to take away 3/8, these 3/8 that we have over here, from our 4/8. And so to do that, I will just cross out 3/8. 1, 2, 3. And some people like to then check these off so they know that they've subtracted everything. And then what we just need to look at is, well, how much do we have left? What we have left is just this section right here, which represents 1/8. And so that lets us know that 1/2 minus 3/8 is equal to 1/8. And when I use our estimated answer to check the reasonableness of that, I know that 1/8 is a very reasonable answer. It is very close to 0. It's just 1/8 away from 0, where it is actually 3/8 away from 1/2. So much closer to 0. So that is a reasonable answer. And this is how we would use area models to subtract fractions.